Okay, hi everybody. So today's session is really about coastal processes. So we'll be learning about types of erosion and transportation happening at the coast. But I want to start first of all with a little bit of recap on the new learning that you did last week about the different types of waves that there are at the coast. Okay, so we learned about constructive and destructive waves. And I want you to just have a little look at the photo there on the screen, which is of the Seven Sisters, which is a very famous cliff formation in the southeast of England. In the area kind of the White Cliffs of Dover. Very similar kind of formation of cliffs. And look at the waves there and think about, are those waves there going to be constructive waves or destructive waves? So you have to think back a little bit to last lesson and what the characteristics of those two types of waves are. So I'm just going to do a quick recap on the whiteboard of what the characteristics of constructive and destructive waves are. Okay, so here's my two basic sketches of the two types of wave. You've got a destructive wave at the top and a constructive wave at the bottom. Now we can tell that this one up here is the destructive wave, partly because of its wave height. So it's got much taller waves, and also the distance between the peaks of the waves is much longer. So this is called the wave length. It's got a much shorter wavelength. The waves are closer together. Okay, and here importantly, this wave as it approaches the beach is called a breaker. Very strong. This is kind of like a surfing wave. Okay, a strong, powerful wave that crashes over on itself up the beach. These sorts of waves occur when energy is high, normally because the wave's travelled a long distance. It's travelled over a long fetch, okay? And that means that they tend to be more erosive. They tend to erode the coast much more. They've got a, remember these terms, swash goes up the beach. The swash on a destructive wave is much weaker. The backwash is much stronger, and because of that it's got an erosive power. It erodes. Erosion takes place. Okay, this one at the bottom is a constructive wave. Okay, much less powerful, tends actually to cause the beach to build up. Constructive builds, constructs, it adds to the beach. Beach builds up. And it's got a much lower wave height, a longer wavelength, so fewer waves per minute if you were going to stand at the coast and count them. And it's got a stronger swash than it has backwash. And because of that, it can carry material up the beach and deposit material on the beach, building that material up. Okay, so those are the characteristics, or some of the main characteristics of our two types of wave. Okay, back to the image then, these cliffs here. Constructive or destructive waves. Have a look at them again in the photo, and I'll give you a clue. A really helpful thing to look at here would be the height of the waves. So you can look at how tall they are. That's going to give you a big clue about whether they are destructive or constructive waves. On the Word document or the PDF document that's attached to this lesson, there's a task for you to do. Task 1 on that Word document, okay, is a task to do in relation to that photo. So go and have a go at that now. Pause this video and then come back. Okay, welcome back. So, coastal processes is what we're learning about today. So we're going to be talking about how weathering and erosion affect the shape of the land at the coast. They're two processes that break down the coast. So we're talking really about areas where you've got destructive waves. They're going to cause erosion, and also where this process of weathering is taking place. We're going to know what they are and how they change the shape of the land, and then what happens to that material once it's been eroded in terms of longshore drift and transportation. So we're going to start with weathering. Okay, here we're going to learn about weathering, and then we're going to go on and learn about erosion. So first of all, weathering. Weathering isn't actually done by the sea, it's done by the weather or other biological processes. Okay, so the first category of weathering is called mechanical weathering. This is, if you think of mechanical, it kind of means like a machine. So mechanical weathering is where the rock gets broken down by some sort of mechanical process, kind of a force acting upon the land. So here's an example of mechanical weathering, which is called freeze-thaw weathering. Imagine like in this first picture here, oh, not good at pointing, this first picture here, okay, you've got a piece of rock and it's got a crack in the rock and it rains and that crack fills up with water. That night, the temperature drops, it gets really cold and the water freezes, and the pressure of the frozen water, because as the water freezes it expands, it puts pressure on the rock and that crack is made wider. And if we're talking about a place in winter, that's going to happen over and over again, possibly every night, every 24-hour cycle. The water's going to freeze and expand, put pressure on the rock and crack it, until eventually that rock breaks into several pieces, or fragments of the rock break off and they fall to the bottom of the hill, if it's a hill. And if they fall to the bottom of the hill, they become known as scree. S-C-R-E-E, scree. The bits of rock that have broken off and fall to the bottom of a hill. So that's an example of mechanical weathering, kind of a force happening, exerting itself on a rock. Another example of mechanical weathering is exfoliation. And this is to do with a temperature change as well, but a really dramatic change in temperature. Not just freezing and melting of water, but this is like the sort of range of temperatures you might get in a desert, where it's really, really hot in the day, up to 40, 50 degrees, and then maybe below 0 at night. Okay, so exfoliation occurs when it gets really hot and the rock's outer layers heat up and they expand. They physically expand when it's so hot, and then at night they contract again. They cool down and they contract. So you get this effect, almost like an onion effect, where the outer layers of the rock start to peel away from the rest of it. That's called exfoliation. So think about the process of exfoliating your skin. That's about taking off the top layer. That's the same here. Exfoliation is the top layers peeling away from the rock because of repeated heating and cooling and extremes of heating and cooling. So they're two examples of mechanical weathering. This is an example of chemical weathering, and we've talked about this before. Solution. Solution is where something becomes dissolved. So when it rains, rock can be dissolved by rainwater, because most rainwater is slightly acidic, and some rocks, particularly things like calcium carbonate, react more easily than others with that acidic rainwater. So you get this kind of effect like you can see in the picture here, almost like the rocks melting away here. This is quite commonly seen on things like some buildings and gravestones as well. And that's an example of chemical weathering. And then finally we've got biological weathering. So this is weathering by plants or animals, flora and fauna. Flora is plants, fauna is animals. So plants can weather the rock because they grow in them. Their roots can break the rock up. The power of roots is really phenomenally strong. Think about pavements which get broken up by the roots of trees, where the pavements kind of get pushed up by the roots of trees. Well, the same thing happens in nature. The rock gets forced apart, cracks get widened by the power of trees and their roots, and other plants as well. And also animals can do this. So things like rabbits can burrow into gaps in rocks. The pressure can force them to crack. So all of these processes together, chemical weathering, mechanical weathering, and biological weathering, can work together to sort of break the rock down and to weaken it. Okay, and if we're talking about at the coast, on this beach here in this photo, for example, these sorts of weathering processes could be happening anywhere on this cliff face here. The sea itself doesn't weather. The sea erodes, and we'll talk about that in a minute. But the sea can only erode this bottom bit of the cliff down here. All of this can be affected by weathering, by those processes I've just talked about. Okay, so there's a good video here. Have a look at this link. It's a good couple of minutes video that just gives you a bit more detail and shows you some examples of those types of weathering. And then on your Word document or PDF document that goes with this lesson, the final activity, I think it's number 6, the final activity is something to do with this, filling in the gaps and drawing some little diagrams of types of weathering. Okay, so go and watch that video, go and do that bit on the worksheet, and then come back and watch the rest of my video. Okay, welcome back. Something else that can happen here then on cliffs is where where a cliff has been weathered by those processes I've just talked about. Something called mass movement can happen, and that's what it is what it says it is: the movement of a mass, a massive amount of material moving. Okay, and in terms of cliffs, it's like this. You might look at this and say that's called a landslide. Okay, a landslide is a type of mass movement. Okay, you'd be absolutely right to say it's a landslide. It's where the land has slipped really under the influence of gravity down the hill. And this happens quite rarely at cliffs on this scale. You get more minor ones of these more often, but on a big scale like this, quite rarely. Okay, but when it does happen, it can have a huge impact on a place. And you can see at the back here, this was a hotel here at the back, and part of it's collapsed with the cliff. There was nobody in it at the time. There are 4 types of mass movement. The first, A, up here, being a rock fall. So this is where bits of rock break away from the cliff, maybe because of something like freeze-thaw weathering, and fall down the cliff. Okay, rock fall, falling rocks. The second, over here, is called a landslide. And actually, the picture we've just looked at, people might look at it and say that's a landslide. But a landslide is actually the movement of blocks of rock. So this technically isn't a landslide, because a landslide would be movement of blocks of rock. That's not rock there, is it? The third one here, mud flow. If soil becomes so saturated, becomes so soaked because it's rained maybe exceptionally heavily for a month, then the soil can become saturated and it just flows down the hill. Okay, a mud flow. And then the last one here, this is what we've just seen in the photo. This is called a rotational slip. And this is where the land actually slips on a curve. See this curve here on the diagram? Okay, it doesn't just slide straight, kind of the head of the land slips down more than the foot of it, and you end up with this kind of terraced effect, a bit like you've got here. Look, you can see these stripes of grass here. And this happens again when it rains heavily, and the water often soaks in through the soil, and then if you've got impermeable rock underneath, rock that the water can't soak into, you end up with, where this black line is here, you end up with like a layer of water, and this acts as a lubricant, and it means that the soil on top can just slide, and it slides in this rotational way, in this kind of curved way. Okay, so again, go back to your worksheet, your PDF for this lesson, and number 3 there's an activity to do relating to that very photograph. Okay, so have a look at that and then come back. Okay, types of erosion now. So we talked about what weathering is, and mass movement. Erosion is done by the sea. So the power of the sea can erode, it can break down the land at the coast. And you'll be pleased to know that there's a bit of a shortcut here, because these are exactly the same types of erosion as when we learned about rivers. Okay, so it's 4 fewer words to learn, helpfully. Okay, so we've got 4 types of erosion that the sea can do. First one is hydraulic action. Imagine, I'm going back to the whiteboard now. Imagine you've got the cliff here. This is the sea. You've got a little crack in the cliff. Cliffs are not solid lumps of rock. They're made up of lots of pieces of rock with cracks and joints and things in between them. Okay, hydraulic action is the power of the water. So in that crack there is air, pockets of air, air bubbles. And when the waves come crashing in and hit this bit of cliff, okay, they put an awful lot of pressure on that air trapped in there. They compress it. And that is what hydraulics is. It's air under pressure. And that air under pressure in turn puts pressure on the rock. And over time, that crack is going to get bigger and widened, okay, and weaker. And it might get broken down by it. So that's hydraulic action. Secondly, we've got attrition. Hopefully this is coming back to you from when we learned about rivers. Attrition. This is the sea here. In the sea, there are lots of bits, mainly pebbles and rock and sandy bits, small bits, bits of shell, all sorts of things. Okay, 2 of these pebbles bang into each other. They wear each other down. They cause each other to break down into smaller and smaller pieces. Okay, that's called attrition. This is why pebbles in the sea and on the beach are so smooth, because they've been bashed into each other over and over again. They've been smoothed by the effect of the smaller particles rubbing on them. They become really nice, smooth, round pebbles. The smoothest ones have been in the sea the longest. Abrasion. Again, I've got my cliff here. Let's label these up, cliff. Okay, cliff here. This is the sea. This is my cliff. You've got these pebbles in the water, and sometimes these get hurled at the cliff. Okay, it can break the pebble down or it can break the cliff down. That's what abrasion is. And the last one, that word solution again. When salts and other acids in the seawater dissolve the rocks of the cliff. Now, not all rocks are equally susceptible to this. Depends what they're made of. But some cliffs, particularly things like calcium carbonate, can get broken down more easily by solution. They can get dissolved. I'm not really very good at thinking of a diagram to draw for that. Okay, so those are our 4 types of erosion. And like I said, hopefully they're the same terms as we came across when we learned about rivers. Right, there's a helpful video again here at the bottom of this slide. Struggling to get this to line up nicely so you can see the PowerPoint again. Okay, might just hold it. There's a nice video at the bottom of this slide here, so go away and have a look at that. And then on your Word document from today here, label diagrams. So hydraulic action, abrasion and attrition. I'm not going to make you think of a diagram for solution because I can't. Okay, so we've got weathering. Weathering's happening up here on the cliffs. Mechanical weathering, biological weathering and chemical weathering. There is, you can see here, where my mouse cursor is just moving around, this bit where you've had a bit of a rotational slump, where that cliff's kind of slipped down a little bit. That's an example of mass movement. And then down here at the bottom where you've got the sea, this is having impact on the cliff nearest the beach down here, and it's starting to erode this down here. So we've got these 3 kind of processes all taking place at the same time. Better just plug that laptop in. Don't go away. I'm back. So those 3 processes are causing the cliffs or the land at the coast to be eroded. What's going to happen to all of that material is what we want to know next. Well, it gets transported by the sea. Okay, it gets carried off, taken elsewhere. And again, helpfully, these processes are the same names as the transportation processes in rivers. So material in the sea gets transported by 4 different methods. Okay, we've got suspension over on the left hand side. Small particles, bits of pebble, bits of sand, float in the water. They're suspended, they're floating. We've got bigger pebbles, get transported by saltation. They're too heavy to float, but they can bounce. They can float for a very tiny amount of time. So they kind of bounce across the seabed, saltation. The biggest particles, the ones on the right, get moved by traction. So they get rolled along. And I said this to you before, I'm sure. My geography teacher at school used to say that this was like the wheels of a tractor. That's how I always remember it. Traction, the biggest particles being rolled along. And then finally, one that you can't think of a diagram for, in solution. So dissolved particles getting carried in solution, floating along, but invisible. So we've got these 4 types of transportation. And there they are. And then finally, there's a special type of process that happens on a beach that causes particles to be transported along the coast. And this is something called longshore drift. Longshore drift. As in along the shore. The shore kind of refers to the beach. Okay, so this is a process that happens at the beach. Just setting up my whiteboard. Okay, so here we have the beach. This is the beach. Here's the sea. And this, for the sake of my diagram, this is the direction of the prevailing wind. That means the direction the wind is coming from. Now, waves are caused by wind, as we know. So the wind is what's blowing those waves onto the beach. So the waves are coming in line with the prevailing wind. Always. Because the prevailing wind is what's blowing them in that direction. So the waves come up the beach like this. So this line here is the swash. The waves swash. Backwash, the way that the waves go out, travel out, back out to sea, they always go out perpendicular to the coastline. So they always go out at like a 90-degree angle here. This is the backwash. And then the next wave comes in, and it comes in like this, the swash, and the backwash goes out like this. And then again, the swash comes in, and the backwash goes out like this. And the next one, the swash comes in, and so on. And if you're a little pebble that's light enough to float in the seawater, you can get carried on these waves, in and out, in and out, in and out, in and out. Okay, and ultimately you're going to be carried along the beach in this direction. So this is what's called longshore drift. And this is the direction of longshore drift. Okay, it doesn't always happen like that. It depends which direction the prevailing wind's coming from. If the wind was coming from this direction, the waves would go in and out, in and out, in and out, and the direction of longshore drift would be that way. Okay, so that's what longshore drift is, and that particularly is a type of transportation that moves particles along a beach or along the coastline, like this. Okay, and again, there's an activity in your number 5 here. Draw the label diagram to show the process of longshore drift and how it affects the coastline. Some key words on there for you to think about making sure you label up onto your diagram. Okay, so your task now is to go through that Word document, make sure you've had a go at all the questions. Any problems, just email me Do watch the video links to other videos in the PowerPoint because they're really useful. They kind of give some real life examples and some footage of things happening in real life, which I can't do with me and my dining room table and my mini whiteboard. Okay, any problems, send me an email and I'll see you later in the week. Take care, everyone.